The universe holds its breath only in silence. But tonight, as you drift toward the comfortable edge of consciousness, listen closely to a story being whispered by the void. We're not talking about a distant galaxy, but an object right here, passing through our solar system, an object called 3I Atlas. For nearly 277 million miles, this cosmic wanderer has been keeping secrets. This is not a metaphor. This is data. The Hubble Space Telescope, that tireless eye in the sky, captured an image of it back in July of 2025, when it was 277 million miles away from Earth. And what Hubble saw was not the usual fuzzy blob we expect from our local, homegrown comets. This was shaped like a teardrop, a cocoon of dust trailing from a solid core. It had structure. It is our third confirmed interstellar visitor. The third time in human history we have caught something that originated around another star, passing through our cosmic neighborhood like a stranger walking through your yard at night. Yet, unlike the cigar-shaped oddity of Oumuamua, the first, this one is different. The data is coming in from multiple telescopes, from spacecraft orbiting Mars, from instruments tuned to every imaginable wavelength of light. And the picture those instruments are painting is not adding up to something simple. We know it has a trajectory that statistically shouldn't exist. We know it is emitting jets of material that violate our simple understanding of how comets behave. We know it survived a close pass by the sun that should have torn it apart. And now, we wait. On November 19th, 2025, NASA is set to finally tell us what they have learned at Goddard Space Flight Center. The announcement promises new imagery that could rewrite how we understand objects from beyond our solar system. But what if the thing we have been tracking for months isn't quite what we thought? What if this visitor is telling us a story we were not ready to hear? Imagine, just for a moment, standing on the edge of all we know, peering into a darkness that holds an object older than our sun, older than our Earth. That pull you feel, that quiet sense of unanswered questions, is the universe inviting you to listen. Leave a comment telling me what time it is and where you are listening from tonight. And then, close your eyes and ask yourself, what is NASA about to disclose that makes astronomers second-guessing their textbooks? We begin our journey where the secrets start, 277 million miles away. The tale of 3I Atlas begins not in fire or fury, but in the quiet, reflective shape of a single celestial body, captured by the lens of the Hubble Space Telescope. Imagine, for a moment, that you are the observer, poised in the velvety dark, looking across 277 million miles of empty space to a visitor that should look like every other comet, yet doesn't. What Hubble saw on July 21st, 2025, was a teardrop, a distinct morphology that defied the usual expectation of a fuzzy, irregular, or roughly spherical coma. This shape, this dust cocoon, was streaming away from a solid core, and it instantly signaled a difference, a diagnostic clue that this object was not a solar system native. When light reflects off a comet's dust coma, the way the dust streams tells a complex story about the object's rotation, its composition, the rate at which it is losing mass, and the specific locations of active regions on its surface. But the teardrop shape of 3I Atlas suggested something far more intricate than simple solar heating, which typically creates a more symmetrical, sun-facing, outgassing pattern. It hinted at multiple active regions, multiple vents jettisoning material. This intricate shedding of its outer layers is the comet's way of communicating its internal physics. You must pause here, as the astronomers did, and consider the sheer distance involved. At 277 million miles from Earth and 3.5 astronomical units from the Sun, most typical solar system comets are still dormant. They have not warmed up enough for significant water ice sublimation. Yet, 3I Atlas was already active, already shedding water molecules at a distance, where a natural, homegrown comet should still be a cold, sleeping lump of ice and rock. The Swift Space Telescope, an instrument primarily designed for gamma-ray astronomy, but equipped with ultraviolet instruments, detected hydroxyl emissions at this extraordinary distance. Hydroxyl radicals, those telltale fragments of water ice, broken apart by the sun's ultraviolet light, confirmed that the visitor was already waking up. Early activation, astronomers call it, and it suggests either a very low sublimation temperature for its ice, or perhaps a more complex mechanism driving the mass loss, a subtle heat source or internal pressure. This is the first piece of the puzzle, the initial quiet anomaly, a structure that defies the simple, fuzzy blob, and an activation distance that stretches the boundaries of our comet models. Consider the sheer age of this object. If, as some models suggest, 3I Atlas is upward of 7 billion years old, it predates almost everything familiar to us. Our solar system is only 4.6 billion years old. This is an object from a time when the galaxy was younger, less chemically enriched. It has been drifting in the freezing dark for eons, accumulating damage from cosmic rays, weathering away molecule by molecule under the erosion of interstellar dust. For it to remain intact, to remain structurally coherent enough to produce such a distinctive teardrop-shaped coma, suggests a durability that exceeds expectation. Imagine a snowball tossed into a cosmic furnace and emerging on the other side still holding its shape. That's the visual paradox 3I Atlas presents. The observation campaign didn't stop with Hubble. To truly understand this visitor, scientists employed multi-telescope synergy. You need more than just visible light. Infrared telescopes, like the James Webb Space Telescope, measured heat. Radio telescopes detected molecules. Spectroscopes broke the light into its component colors, revealing the chemical fingerprint of what was present. The James Webb Space Telescope detected carbon dioxide in the coma, a finding that will become profoundly significant later in our journey. Radio arrays, such as the ones in South Africa, picked up those telltale hydroxyl emissions, confirming the presence of sublimating water ice, even at that immense distance. Different windows into the same object, each one adding a new, sometimes conflicting, detail to the portrait. This concerted, global observation campaign turned a routine comet detection into something that demanded a press conference at Goddard Space Flight Center. It's the sheer multiplicity of anomalies, the clustering of unexpected data points in one object, that gives pause. The teardrop shape, the early activation, the suggested durability. These are the first ripples on the pond, the first gentle cues that the cosmic wanderer is not just a random rock, it's a moment in time when the technology of humanity finally meets an object that challenges the textbooks we have cherished for centuries. The quiet tension we feel is the anticipation of 2025's great reveal. But to understand the secrets of the teardrop, we must first follow its path, a path that took it unnervingly close to our planetary kin, Mars. The path of 3I Atlas through our solar system, its orbital mechanics, provides the second profound layer of mystery. Imagine the solar system as a vast, ancient clockwork mechanism. The planets all spin in one direction, counterclockwise, moving on a single, relatively flat plane we call the ecliptic. This consensus of motion is a leftover from the angular momentum of the gas and dust disk that formed everything 4.6 billion years ago. An interstellar visitor, coming from outside this established system, should have a random, chaotic trajectory, arriving from any direction, at any steep angle. But 3I Atlas did not. It moved retrograde, orbiting the Sun backwards compared to the planets. That, by itself, is not strange. Random arrivals should be 50% prograde and 50% retrograde. The peculiar detail is that this retrograde orbit is tilted only about 5 degrees from the ecliptic. It was coming in almost aligned with the flat plane where Earth and the other planets orbit. The statistical probability of an interstellar object arriving nearly aligned within just a few degrees of our planetary plane is an almost impossibly low 0.2%. 2 in 1,000, an outlier that makes the quiet mathematician in you pause. But why does this low inclination matter? Because an object entering the solar system at a low inclination has a vastly higher chance of passing close to multiple planets. It stays in the busy plane of traffic. An object with a steep 60 or 70 degree inclination might sail through and leave without ever getting close to anything interesting. But 3I Atlas threaded through the inner solar system as if it knew the way. It passed near Venus's orbital distance. Most importantly, it approached within just 18 to 19 million miles of Mars on October 3rd, 2025. This Mars flyby is what elevates the trajectory from merely strange to suspiciously precise. 18 million miles sounds vast, but astronomically, it is uncomfortably close. Mars's orbit around the Sun is about 140 million miles in radius. The visitor passed at about 13% of that orbital radius. It was threading a needle while blindfolded, a path that seemed almost precisely calculated to give us the best possible viewing opportunity from multiple planets. The true marvel of this close pass, however, lies not just in the geometry, but in the engineering that was waiting. The European Space Agency's ExoMars Trace Gas Orbiter, which has been diligently circling Mars since 2016, suddenly found itself with a perfect vantage point. This orbiter, designed to study Martian atmospheric chemistry, pivoted its instruments toward the interloper. The result was extraordinary, a 10 times improvement in trajectory accuracy. Before those Martian observations, we knew the orbit roughly, with an uncertainty that translated to within a few light years in its point of origin. After the Trace Gas Orbiter and other Martian spacecraft tracked it, that uncertainty dropped by a factor of 10. We now know exactly where it came from and exactly where it is going, with a confidence unprecedented for an interstellar object. This precision matters. It allows us to work backwards and figure out which stellar neighborhood it likely called home billions of years ago. But it also adds an uncomfortable statistical dimension, that it arrived with a low inclination, maximizing its time in our planetary plane, and then pass so closely to a planet with advanced robotic observers, maximizing the data return, starts to look like a fine-tuned trajectory. Some have called this phrase loaded, borrowed from cosmology, where it implies design. In this context, it simply means the orbit seems optimized for our observation. We have detected 3 interstellar objects in 8 years. Statistical models suggest thousands pass through the inner solar system at any given time, most too small to detect. The objects we see are the bright, large outliers. But what are the odds that one of the first 3 we detect has all these orbital peculiarities? Low inclination, retrograde motion, and close planetary approaches aligned for optimal observation. Each one is improbable but possible. All of them together start to look like a pattern. The counter-argument, of course, is that 3 is a small sample size. Perhaps all interstellar objects have weird orbits for reasons we don't yet understand. The universe is big. Weird things exist. But the scientist inside you, the one trained to ask for a mechanism, for a physical cause, cannot simply shrug and say, random chance. The path of 3I Atlas, its journey, is a quiet defiance of statistical expectation. It arrived with this specific inclination, this specific timing. Was it ejected from its birth system at just the right angle to wander into our plane? Or is the object's trajectory navigated? The Mars Pass gives us the precision to ask this question with a degree of confidence we never had before. The tenfold improvement in trajectory accuracy is the quiet truth that will allow scientists to peel back the layers of this ancient object's history. It tells us that we can now trace its origin to a specific region of the galaxy, but to know where it came from is only half the story. The other, far stranger half, lies in what it is actually made of, and the chemical composition revealed by the light is about to provide an unexpected, colorful, and unsettling surprise. To understand what 3I Atlas is, we must look beyond its movement and its shape, and instead read its chemical fingerprint, the language of its component atoms and molecules. Chemistry, as the adage goes, does not lie. When a spectroscope breaks the light from the comet's coma into its component colors, we are reading the unique signature of every element and molecule present. And the signature of 3I Atlas is not a familiar one. It is, in the dry language of science, wrong. Let's begin with the data from the James Webb Space Telescope, that powerful infrared eye. Webb looked at the coma, the vast cloud of gas surrounding the nucleus, and precisely measured the ratio of carbon dioxide to water. In our local solar system comets, which formed beyond the orbit of Jupiter, you might expect a carbon dioxide to water ratio of maybe 1:1 or 2:1, especially if it formed far out where carbon dioxide ice is stable. This is a normal range for a familiar, natural object. But 3I Atlas defied this norm. Its ratio was 8:1, 8 parts carbon dioxide for every 1 part water. This is not merely unusual. It places the object in a completely different chemical family from almost everything else we have studied. Why does this matter? Because where you form determines what you are made of. In our solar system, we talk about the snow line, the distance from the sun where it is cold enough for water ice to condense. Beyond that, as you move further into the void, you cross other condensation distances for progressively colder volatiles, such as carbon dioxide, carbon monoxide, nitrogen, and methane. The composition of a comet is a precise record of the temperature and pressure conditions in its birth environment. A composition dominated by carbon dioxide suggests formation in a region where carbon dioxide ice was abundant, yet water ice was relatively scarce. This can happen naturally, but it strongly implies a stellar environment very different from ours. Perhaps a star with a different temperature profile, a proto-planetary disk with a different chemistry, maybe even a lower metallicity altogether. Metallicity, in astronomical terms, refers to the abundance of elements heavier than hydrogen and helium. We, in our solar system, are made from recycled supernova material, elements forged in stellar cores and scattered by explosions. An object from an older stellar system, before the galaxy was so richly enriched with heavy elements, might naturally lack some of those enrichments. Now, layer this compositional bombshell with another, even stranger finding: the polarization issue. Multiple teams conducted polarimetric observations, measuring how light reflects off the dust particles in the coma. This subtle measurement tells us about the grain size, grain shape, and surface properties of the dust. What they found was unprecedented. 3I Atlas exhibits what is called an extreme negative polarization branch, reaching -2.7% at a 7-degree phase angle. No known asteroid or comet in our solar system shows this signature. None. The closest analogies are found only in some laboratory samples of highly unusual grain structures. It is like finding a mineral that should not exist according to our familiar periodic table. The polarization tells us the dust grains are unusual. Perhaps they are much larger, or shaped more irregularly, or composed of materials that reflect light in ways we have never encountered. Why would an interstellar object have such different dust properties? What does that reveal about the violent processes that shaped it? The chemical composition is not, in itself, impossible. The presence of an 8:1 carbon dioxide ratio is not evidence of wrongdoing, but it is so far outside the comfortable norm that it demands a profound explanation. The simple, natural explanations suggest different starting conditions, a different star, a different stellar disk. But the alternative interpretation, the one that gets whispered about more than stated outright, suggests deliberate design. If you were designing an object to survive a billion-year interstellar journey, you would reinforce it with metals. You would use materials optimized for durability, not for planetary formation chemistry. Such an object might produce an unusual elemental signature, something that looks processed rather than pristine. The unusual nickel-to-iron ratio, suggested by some circulating spectroscopic observations, points toward this idea. Elevated nickel-to-iron content is characteristic of metallic cores, of processed and differentiated bodies. If 3I Atlas shows this elevated metallic content, it suggests either a fragment of a destroyed planet's core, wrapped in an icy mantle, or something even stranger, something engineered for cohesion and durability. So, the compositional story is a tapestry woven with 3 unsettling threads: carbon dioxide domination, extreme negative polarization, and possible metallic enrichment. Each can be individually explained, but all 3 together, in one single object, keep pushing at the edges of our model labeled ordinary interstellar comet. And given what this object is made of, the manner in which it behaves only gets stranger, especially as we observe its violent, eruptive, and seemingly controlled outgassing. The heart of the mystery of 3I Atlas is not its static composition, or its orbital trace, but its dynamic behavior. We learn what something is by watching what it does, by measuring its motion and its reaction to external forces. And when we look at how this visitor responds to the fierce radiation of our sun, it behaves in ways that break the established models. When a normal comet approaches the sun, the side facing the intense solar radiation heats up unevenly. The ice on that sunward side sublimates, turning directly from solid to gas. This builds pressure and erupts outward in jets from active regions, usually clustered on the day side. These jets are the comet's tiny, self-regulating rocket engines. They create a small, non-gravitational acceleration that alters the comet's trajectory slightly, a well-understood physical process. The crucial detail is that these jets, these tails of gas and dust, always point away from the sun. Always, because that is the direction of the pressure and the heat. Except, 3I Atlas takes this to an extreme, and in one particular instance, it appears to move in quiet defiance of this law. Images from the Gemini Observatory and other ground arrays revealed something astonishing in the post-perihelion data, taken after the object had rounded the sun and was heading back out into the dark. They captured a prominent, sunward-pointing jet, a jet aimed toward the sun, the very source of the heating that is supposed to drive the material away. This is the central paradox of its behavior. How does a natural comet, driven by simple solar heating, fire a jet of gas and dust into the solar wind? The easy answer is rotational mechanics. Perhaps the object is spinning, and an active vent on one side might fire while pointing sunward during a part of its rotation period. But for this to produce a prominent, sustained jet, the vent would have to remain active and aligned in a very specific, almost contrived way. Another possibility is internal pressure cavities. Perhaps gas builds up deep inside the nucleus, finds a weak spot, and erupts wherever it can escape, regardless of the sun's direction. A subsurface structure channeling pressure in unexpected ways. But the peculiarity of the jets does not end there. The observations also show remarkable stability and columnation. Columnated means focused, narrow, and not spreading out quickly. These jets maintained their structure over thousands of miles, far better than you would expect from the rapid gas expansion and turbulence that should quickly diffuse a natural cometary jet. They stayed directional, which suggests either a very specific vent geometry that acts like a nozzle, or some kind of channeling mechanism that maintains the pressure and focus. Natural comets can do this to some extent, but 3I Atlas seems to maintain this structure better than average, better than it should if it is just ice and rock. The mystery deepens when you consider its durability. 3I Atlas passed within roughly 1.4 astronomical units of the Sun. That is inside the orbit of Mars, well into the inner solar system, where thermal stress is intense. Many typical comets do not survive this thermal stress. They fragment. They disintegrate into clouds of debris, but 3I Atlas remained intact. Post-perihelion observations confirm it still has a well-defined nucleus, still producing jets, still structurally coherent. This suggests extraordinary internal cohesion. One natural possibility is that it is not as icy as we think. If it has a significant rocky or even metallic component, providing a structural skeleton, like rebar in concrete, that could hold things together even as the ice ablates away. Another possibility is that the ice itself is unusual, perhaps crystalline rather than amorphous, or contaminated with heavier molecules that raise its melting point, or sealed by a tough organic crust moderating the heating rate. These are all natural explanations, requiring only that interstellar objects can have properties outside our local experience. But when you circle back to those jets, the ones that fire in multiple directions, the ones that stay collimated for thousands of miles, the ones that seem to turn on and off in patterns that don't quite match solar heating curves, the possibility of active management creeps in. What if these vents are positioned, shaped, and triggered in ways that serve a purpose beyond simple sublimation? Engineered vents, for the purpose of propulsion or course correction, would look a lot like what we are seeing, precisely aligned, sustained over long durations, capable of producing thrust in specific directions. If you wanted to fine-tune your trajectory as you approached a star system, you would use exactly this kind of system: controlled outgassing, directional jets, and non-gravitational acceleration. No official statement claims that this is an engineered system. Not yet. But the dynamic behavior of 3I Atlas, its resistance to destruction, and its ability to fire jets toward the sun, does not fit comfortably into the standard Comet models that work perfectly well for 99% of observed objects. In a sense, the object is exhibiting a toughness, a structure, and a pattern of outgassing that suggests it is more actively managed in its mass loss than a typical random rock. The question that hangs over every measurement is whether that management is natural, a rare alignment of unusual physics, or something else. The sheer weight of the anomalies surrounding 3I Atlas has created a rare and fascinating split in the scientific community. It is an argument fought not with angry words, but with competing hypotheses, each one trying to explain the data better than the last. And the chasm between the two primary explanations reveals more about our collective willingness to consider the unknown than it does about the object itself. On one side, you have the mainstream scientific interpretation. This view, which is likely correct in a conservative, purely physical sense, asserts that 3I Atlas is a natural object. Yes, it is profoundly unusual. Yes, its composition is odd, its trajectory improbable, its jets defiant, but space is vast, and the universe is an infinite engine of the improbable. Stellar systems can have wildly varying chemistries, and we have only studied a tiny fraction of the comets, even in our own solar system. This is an outlier, an edge case, a natural curiosity. The simple fact that it exhibits cometary activity, a dust coma, outgassing, is consistent with an icy body responding to solar heating. Nothing about it, this narrative claims, requires exotic physics or non-natural explanations. Recent radio observations from the Mir Cataray in South Africa, for instance, detected emissions that perfectly match hydroxyl radicals produced by water ice sublimation. Natural processes, natural signatures. Occam's razor, the philosophical principle that the simplest explanation is usually the best, strongly favors this view. But then there is the other interpretation. The person most associated with this alternative view is Dr. Avi Loeb, a Harvard astrophysicist with credentials that cannot be easily dismissed and a willingness to say what others won't. Dr. Loeb has compiled a list of 12 anomalies associated with 3I Atlas. His argument is not that any single anomaly proves artificiality, but that the combination, the pattern, the clustering of unlikely events in one object forces us to at least ask the question, what if we are looking at something technological rather than natural? Let us quietly review a few of these 12 points. We have already covered the first few. The retrograde orbit that is tilted only 5 degrees from the ecliptic, an arrangement whose statistical probability is only 0.2%. We have discussed the impossible sunward anti-tail jet. We know of the close approach path, a trajectory that seemed to maximize observation opportunities from multiple planets, including the unprecedented pass near Mars. The list continues with the nickel-iron spectral signature, the possibility of elevated metal content that does not match pristine cometary composition. Then there is the unprecedented polarization signature, that negative 2.7% reading that matches no known solar system object. The list goes on, including rapid mass loss without disintegration, suggesting a remarkable internal strength. The list also includes early water activation at 3.5 astronomical units and stable multidirectional jets that maintain collimation over large distances. Imagine you are rolling dice. If you roll 12 sixes in a row, you do not immediately conclude the dice are loaded, but you certainly start checking. You start asking questions. You do not simply shrug and say, coincidence happens. The alternative interpretation says, what if 3I Atlas is a technological artifact? Not necessarily a spacecraft with living beings inside, but an engineered object, a probe, a beacon, a buoy, something created by intelligence and sent on an interstellar journey. The unusual composition becomes deliberate design. The stable jets become controlled propulsion. The durability becomes engineering. Everything that looks strange through the lens of random chance begins to make logical sense through the lens of intentional design. Here is the central philosophical divide. The natural hypothesis states, physics plus random chance equals a weird comet. The alternative hypothesis states, engineering plus intentional design equals a surveillance probe or similar artifact. Both hypotheses explain the data. Neither can be definitively proven with the current observations. And this ambiguity is what makes the situation so maddeningly compelling. Most scientists side with the natural explanation because that is the bedrock of scientific rigor. You do not claim extraordinary things, like artificiality, without extraordinary evidence. And so far, while the evidence is highly unusual, it is not yet extraordinary enough to overcome the massive burden of proof required for an artificial origin claim. But what if, Dr. Loeb asks, that standard is wrong? What if waiting for extraordinary evidence means missing the obvious? What if we are so committed to natural explanations that we cannot see the artificial one staring us in the face? That is the quiet tension that the reveal on November 19th will drop right into the middle of. Whatever NASA says, whatever new data they share, it will be used by both sides to support their existing interpretation. And as you listen, you will have to decide for yourself which story you find more believable, because to choose one is not just an act of science, it is an act of cosmic belief. Every object in the cosmos is a tiny, perfect historian. It carries the fingerprints of its origin, the scars of its journey, and the silent, measurable marks of time passing. 3I Atlas is no different, except its history may stretch further back than almost anything else we have ever studied. It is older than our solar system, older than Earth, old enough that when it formed, the galaxy itself looked like a younger, less developed place. We know one thing for certain: 3I Atlas is interstellar. Its trajectory is purely hyperbolic, meaning it is not gravitationally bound to our sun. It came from somewhere else entirely, and it is leaving, never to return. The incredible precision now available, thanks to those orbital measurements taken by the Mars orbiters, allows us to narrow down its origin to a general region of the galaxy. We cannot yet pinpoint the specific star, not yet, but we can see the volume of space, dozens or hundreds of light years across, where it likely formed. But the true mystery is not where, but when. This is where the data thins out, and we must rely on educated guesses based on indirect evidence. Some researchers, examining the data related to surface weathering and cosmic ray exposure, have tentatively suggested an age upward of 7 billion years. 7 billion. For context, our Sun is about 4.6 billion years old. The Earth is 4.5 billion. If 3I Atlas is truly 7 billion years old, it is a living fossil from an era when the galaxy was younger, less chemically enriched with heavy elements, an era when stellar formation rates were different. It predates almost everything we consider familiar. How do you date an interstellar object when you do not have a sample for radioactive decay? You look at its scars. The vacuum of space is permeated by cosmic rays, high-energy particles that gradually damage surface materials over time. They sputter atoms, they create microscopic defects, they change isotopic ratios in measurable, predictable ways. If you can measure this accumulated damage, if you can compare it to laboratory experiments and theoretical models, you can estimate the object's exposure age, how long its surface has been exposed to the interstellar radiation environment. This 7 billion year estimate is tenuous, a whisper based on general principles and comparisons to other bodies where we do have better data. But if it is even close to the truth, the implications are staggering. Consider the formation scenario. An object this old formed in a stellar system that may no longer exist. Stars live and die. Our own sun will last about 10 billion years. A 7 billion year old object could have been born around a star that went supernova eons ago, scattering its planetary system into the void, or a star that evolved into a white dwarf, consuming or ejecting its planets. 3I Atlas might be the single, last surviving remnant of an ancient system, a fossil carrying the chemical signatures of a dead civilization of worlds. The carbon dioxide domination, that 8:1 ratio from the James Webb Space Telescope observations, supports this unusual origin story. That much carbon dioxide suggests formation near the carbon dioxide ice line in its birth disk, and the location of that ice line is utterly dependent on the star's luminosity and the disk's properties. The specific chemistry of 3I Atlas implies formation conditions that we can model, conditions that point toward an environment different from ours. Lower metallicity maybe, different volatile abundances, conditions that existed more commonly 7 billion years ago than they do now. Think, too, about the journey. If this object spent billions of years traveling through interstellar space, it would have been eroded, sandblasted by interstellar dust and micrometeorites, collecting a surface layer of new, accreted material. This long journey, this patina of everything it passed through, might mask the object's true original composition. We may not be seeing the pristine surface, but rather a compressed layer representing billions of years of accumulated history. But the question remains, if this object survived billions of years, enduring the brutal, erosive reality of interstellar space, why does it remain intact? Natural objects fragment, they erode, they break apart. The fact that 3I Atlas remains structurally and dynamically functional, still capable of controlled seeming outgassing, suggests either extraordinary luck or extraordinary engineering. Durability, in this context, is not a byproduct. It becomes the point. If it was designed for a billion-year journey, its survival is not a coincidence, but the result of the initial, deliberate composition. The long lifespan, if accurate, makes the anomalies more statistically significant. An object this old, from an earlier, less enriched galactic epoch, carrying a chemical signature from a younger galaxy, is a message in a bottle. And if we can read it, if we can truly decipher what its composition tells us about its birth, we might learn things about cosmic evolution that we could learn no other way. The 7-billion-year mystery is the quiet, mythic echo in the story of 3I Atlas. We exist in a sliver of time, a thin edge of history so brief it barely registers on the scale of 3I Atlas's 7-billion-year journey. Yet, this sliver is the golden age of discovery. The object is ancient, but the technology that found it is impossibly new. This juxtaposition of deep time and instantaneous observation is the human reflection in the story of the interstellar visitor. Imagine, for a moment, the astronomers of decades past, building careers around the idea that objects from other star systems must occasionally wander into ours. They wrote complex papers, speculating on what such visitors might tell us about the chemistry of distant stellar neighborhoods, or about the violence of planetary formation elsewhere. Many of those dedicated people never lived to see it happen. The universe kept its secrets close, its hands clasped tightly around its history, and then, suddenly, in the span of just 8 years, 3 of these wanderers showed up, one in 2017, another in 2019, and now this one, 3I Atlas, in 2025. The sudden, rapid succession is not a sign of increasing cosmic traffic. It is a profound testament to human ingenuity. The detection rate is limited only by our technology and our survey programs. We built the instruments, the ground-based observatories in Chile, Hawaii, and South Africa, the space telescopes like Hubble and the James Webb Space Telescope, and the specialized spacecraft orbiting Mars. We built the technology, and the universe immediately responded. We are alive at the exact moment in human history when this happens, and we have the capacity not just to see it, but to analyze it with extraordinary fidelity. We can look at 3I Atlas's light, break it into its component colors, and know what its coma is made of. 8 parts, carbon dioxide to 1 part, water, a chemical signature from a place we will never visit. We can watch its jets, that defiant, sunward-pointing stream of gas, and measure its motion with such precision that we can trace its origin back billions of years. This is the power of the human reflection, the ability to transcend our local physical reality through measurement and curiosity. Think of the complexity required to achieve this. We did not just look once. We looked again and again, from different angles, with different instruments, at different wavelengths of light. This is the process of building a picture piece by piece, like solving a puzzle where most of the pieces are invisible. That is what turned a routine object detection into an event that demanded a NASA press conference. The tension in the story of 3i Atlas is the tension between awe and intellect. The awe is the profound, spiritual feeling that you are staring at something older than the foundation of your world, a relic from a dead stellar system. The intellect is the rigorous, dry determination to apply Newtonian physics, spectroscopy, and orbital mechanics to every single anomaly. The mainstream scientist operates under the assumption that even the strangest data point can be accommodated by known, natural laws, no matter how far they have to stretch the parameters. But the human impulse, the philosophical part of our being, wants the more dramatic story. We are the species that looks up and asks, what if we are not alone? When the radio telescopes, like the Meerkat Array, detect natural hydroxyl emissions, the scientists conclude, case closed, it's a comet. But the human, the philosopher, quietly asks, when you have to specify that something is natural, it means someone asked if it might not be. The question is now on the table. And once the question is on the table, once we are seriously considering whether an object from interstellar space might be something other than a random rock, then we are not just doing astronomy anymore. We are doing something else. This object, passing so swiftly through our collective yard, is forcing us to confront a fundamental question we have spent centuries avoiding. It is testing the very limits of our scientific humility. Is the pattern of the 12 anomalies a coincidence, the random alignment of 12 unique physical traits in a single object? Or is it a whisper of design, a signal that our universe is populated by ancient engineering, a possibility we have only just gained the technology to perceive? The great reveal on November 19th will not be the end of the mystery. It will be the moment when the human species, standing at the peak of its observational capability, receives a data dump from an object that has traveled across 7 billion years of cosmic history. The entire civilization, everything we have built and thought and created, fits into a sliver of time so thin it barely registers on the scale of this object's journey. And yet, we are the ones listening. We are the ones asking. And that relentless curiosity, that drive to find an answer, is what truly defines this golden age. We may already be part of the experiment. In the quiet, patient process of science, an outlier is never simply dismissed. An outlier is a signpost, a small tear in the fabric of the comfortable, established model. And the story of 3i Atlas is not one outlier, but a dense constellation of them, forcing scientists to stretch their models to the very limits of plausibility. Think about how our understanding of comets was built. Over centuries, we have measured hundreds of comets and asteroids in our own solar system. We know what normal looks like. Normal means that the dust coma is a fuzzy blob. Normal means that the jets of sublimating ice fire away from the sun. Normal means that the composition falls within a predictable ratio of carbon and water relative to its distance from the sun. When 3i Atlas arrived, it immediately violated these simple rules. Let's return to the dynamic anomalies. The fact that it survived a close pass of 1.4 astronomical units from the sun without fragmenting is a structural anomaly. Most comets would be torn apart by that thermal and tidal stress. Its survival requires an internal cohesion, a strength that exceeds expectations. The models scientists build to explain this durability require them to use non-standard parameters. They suggest a higher tensile strength than typical cometary material, a lower porosity meaning it is more solid and less fluffy, and compositional heterogeneity, with hard parts and soft parts arranged to distribute stress. All of these adjustments push the model away from the average comet and towards something that is sitting right on the edge of the parameter space. Then you have the multi-directional, columnated jets. The sunward jet alone is an immense challenge to the simple solar heating model, but the persistence of the jets is also an outlier. Gases are exploding outward at hundreds of meters per second. This force should erode the vent walls and change the geometry over time. Yet, the jets persist with little variation over days and weeks. It is like a garden hose maintaining a perfectly focused stream, even as the nozzle is made of soft material that should be wearing away rapidly. It is only possible if the vent is made of a very hard, high-strength material, or if there is some kind of self-limiting, pressure-regulating mechanism at work. Now, consider the compositional outliers again. The 8:1 carbon dioxide to water ratio. This is a massive chemical fingerprint, suggesting formation in an environment where carbon dioxide was far more stable and water was scarce. The sheer dominance of carbon dioxide puts it in a chemical family distinct from everything else. And the spectral hint of an unusual nickel to iron ratio in the coma material suggests the presence of metallic, processed material, not pristine ice from a protoplanetary disk. These three groups of anomalies, the extraordinary strength, the defiant jets, and the unusual composition, act as scientific gates. To walk through the gate labeled natural comet, you must stretch the existing model to its breaking point to accommodate all three. You must accept that an object can be 7 billion years old, yet structurally sound, fire jets, in the wrong direction due to an incredibly complex and lucky rotational vent alignment, and be composed of a unique, previously unseen ratio of elements from a far-off stellar system. The person who chooses the alternative hypothesis simply says, why stretch the natural model when a technological model explains the data more simply? If you were designing a durable, self-propelled probe, you would reinforce it with metal. You would give it controlled, directional thrusters, and you would choose a composition that balances strength with mass efficiency. The extreme stability and columnation of the jets become the signature of an engineering footprint. The tension is this: the scientific method demands that we exhaust all natural possibilities before invoking something as extraordinary as an artificial origin. That is the rule of science. But what if the natural possibilities, when exhausted, still leave a highly improbable residue? What if the simplest natural explanation is, in fact, incredibly complex and statistically contorted? The outlier problem is an opportunity. It means we are learning, whether we confirm that space rocks are simply much tougher than our models predict, or whether we discover that we are not alone in the universe. The fact that these three specific, highly improbable anomalies are clustering in the same object is what bothers the most rigorous minds. It is like a quiet, insistent ticking in the data. And on November 19th, NASA will present their final, polished model, and we will see whether that model has finally accommodated all the weirdness or whether it has left a few uncomfortable pieces still on the table. The universe, in its boundless indifference, occasionally presents us with patterns that strike the human mind with the force of myth. These are not scientific laws, but archetypal echoes that resonate deep within our collective subconscious. The return of the comet, the significance of threes, and the unnerving suggestion of non-randomness. And the story of Three-Eye Atlas is rich with this quiet, profound patterning. First, the most obvious. This is the third confirmed interstellar visitor ever detected by humanity. The ancients revered the number 3, life, death, and rebirth, maiden, mother, and crone. In the modern era, our detection of these wanderers has arrived in a quick trinity: Oumuamua in 2017, Borisov in 2019, and now Three-Eye Atlas in 2025. The timing is too rapid to be a coincidence of cosmic traffic. It is a coincidence of human technological ascent. The mythic component is the subtle feeling that the universe was waiting for us to achieve a sufficient level of observation before it began sending messages in a bottle. Then, consider the clustering of anomalies. Dr. Loeb's list of 12 peculiarities. In numerology, 12 is the number of cosmic completion, of cycles, 12 months, 12 hours, 12 signs of the zodiac. The existence of 12 separate, individually improbable anomalies in a single object, the 5-degree orbital tilt, the sunward jet, the non-disintegration, the polarization signature, the early water activation, is a statistical nightmare. When you roll dice and get 12 sixes in a row, the mythic part of your mind whispers, "This is too perfect to be random." The pattern itself becomes the evidence. The universe is not supposed to be so neat, so prone to clustering its weirdest elements in one single visitor. And finally, consider the question of deep time and return. If Three-Eye Atlas is truly 7 billion years old, it is a relic from the universe's youth, a message from a time when the galaxy was younger and less chemically enriched. The journey it has undertaken, drifting for eons between stellar systems, is an immense, unquantifiable epic. The mythic echo here is the cosmic fossil. It is the last surviving remnant of an entire stellar system that has since died, gone supernova, or faded into a white dwarf. It is a physical artifact of a civilization, perhaps, that existed billions of years ago and is now merely dust. This sense of return, of an object that has been wandering since before time as we know it, only to arrive precisely when we have the instruments to measure it, contributes to the unsettling feeling of non-randomness. It is the timing, the sheer audacity of this alignment that suggests an almost intentional visit. This object took a trajectory that brought it near Venus, then past Mars, maximizing the opportunity for observation from our planetary network. It threaded through the inner solar system like an impossibly good archer. The orbit, in its improbability, seems fine-tuned. We must step back and appreciate the profound, almost poetic nature of this cosmic coincidence. In an indifferent universe, where a sheer, brute force random entry is the statistical norm, this object has chosen the statistically improbable path, the low, 5-degree inclination that kept it in the planetary plane, the exact timing that brought it into the observational sweet spot of the Mars orbiters. This is the mythic component, the sense that the cosmos, for a fleeting moment, has bent its own rules. The scientific mind rebels at the word mythic. Science seeks to explain the seemingly magical through the mundane laws of physics. But the human mind, the deep, reflective part of you listening in the dark, understands that patterns are the language of intention. If this were a natural object, it is a 1 in a million case, the statistical anomaly that reminds us that even random chance produces spectacular extremes. If this is an artificial object, then the patterns, the 3s, the 12s, the fine-tuned orbit, are the subtle, deliberate communication of an ancient engineering. The gentle humor here is in the tension itself. Our greatest technological achievement, the ability to look across 277 million miles and read a chemical ratio, has brought us a relic that makes us feel like the ancients again, staring at the sky and wondering if the gods are sending us a sign. But this time, we have the tools to check the dice. We have the science to analyze the pattern. The mythic echo simply reminds us that the question is bigger than just comets. It is about where we fit into the universe's grand, improbable story. The answers, though, may be in the most subtle of data, the radio waves we thought we had already explained. If 3I Atlas were an engineered object, a relic of an ancient technological intelligence, how would we know? This is no longer a question confined to science fiction. It is a legitimate field of inquiry, known as the search for techno-signatures, any evidence of technological activity beyond Earth. This due diligence includes pointing radio telescopes at the anomalous visitor, teams using the Meerkat Array in South Africa, a cutting-edge collection of radio dishes, observed 3I Atlas as it passed through the inner solar system. They were listening for the unmistakable signs of artificiality, narrowband signals, modulated patterns, anything that could not be explained by a natural process. And they did, in fact, find something. They detected radio emissions. But before the excitement or the worry takes hold, let us quietly consider what they actually found. They detected hydroxyl radical emissions. These are the expected, entirely natural byproduct of cometary activity. When water molecules, sublimating off the comet's icy core, get broken apart by solar ultraviolet radiation, the resulting oxygen and hydrogen fragments, particularly the hydroxyl radical, emit radio waves at specific, well-known frequencies, primarily around 1,800 megahertz. This is a completely standard, well-documented, and expected process. The official conclusion, therefore, is that the radio detection, rather than supporting an artificial origin hypothesis, reinforces the natural one. The comet is outgassing water. The water is being photodissociated by sunlight, and the resulting hydroxyl radicals are radiating at the frequencies we expect. Everything fits the standard model. Case closed, but not quite. The Meerkat observations covered multiple frequencies and time periods. The hydroxyl line is only one feature. The lingering question, the one that keeps the curiosity quietly alive, is whether there were other, unexplained signals, even weak, intermittent patterns that fall below the significance threshold required for an official, peer-reviewed finding. This is the realm of careful, necessary speculation. There are researchers, serious and credentialed, who suggest there are subtle electromagnetic anomalies associated with 3I Atlas. They are not the strong, unambiguous signal that would end the debate instantly. Rather, they are weak, intermittent patterns that do not quite fit the perfectly smooth natural models. They hint at possible magnetic field variations or plasma interactions with the solar wind that seem structured rather than purely turbulent. Nothing conclusive, nothing that would survive peer review without numerous alternative, natural explanations, but just enough to keep the question gently on the table. The possibility of magnetic fields is particularly interesting. When a comet approaches the Sun, the solar wind, that constant stream of charged particles flowing outward from the Sun's corona, interacts with the comet's coma. This creates a magnetic field structure, a bow shock, that deflects the solar wind. We understand the physics of this process. But if 3I Atlas has an unusual interior, perhaps a metallic core or highly conductive materials, which the nickel-iron spectral signature hinted at, that internal structure could alter the magnetic field geometry in detectable ways. Furthermore, if the object is engineered, if it has internal power sources, or is actively generating its own electromagnetic fields for any reason that would create a magnetic signature distinct from a passive solar wind interaction. The great difficulty in this search is epistemology. How would we recognize a technological signature if we saw one? We know what natural looks like. We have studied thousands of solar system objects. But alien artificiality? We have one example: human technology. And human technology might be completely unrepresentative of what ancient, advanced alien engineering would produce. The classic SETI approach searches for narrowband radio emissions, the signature of transmitters. But what if the advanced technology operates in frequency ranges or modulation schemes we haven't thought to check? What if the signature is in something we are already measuring, but interpreting as noise or natural variation? 3I Atlas could be silently screaming its artificiality, and we would not know because we are not listening for the right language. That is the uncomfortable, necessary possibility. It suggests that we need a comprehensive, multi-spectrum monitoring approach to all interstellar objects, not just radio, not just visible light, but everything. 3I Atlas, unlike the completely normal-seeming comet Borisov, and unlike Oumuamua, which showed anomalous acceleration without outgassing, falls into a frustrating middle ground. It is clearly active, clearly outgassing. The radio data supports a natural origin, but it does not absolutely rule out a more complex one. It is not proof, but it is evidence. And the entire narrative of this object is built on this central theme. Individual measurements can be explained naturally, but the ensemble, the pattern, keeps nudging us toward the extraordinary. As you drift, consider the subtle whispers in the static of the universe, and how often a simple, natural explanation is also a curtain drawn over a far deeper mystery. The story of 3I Atlas is ultimately a reflection of the human journey, our slow, painstaking, and often humorous ascent from myth and superstition to the demanding rigor of the scientific method. It reminds us that our desire to find meaning, to find connection, is so strong that we often see patterns where only noise exists, a psychological phenomenon known as pareidolia. For centuries, before the advent of the scientific telescope, comets themselves were terrifying omens. They were the harbingers of doom, the tears of the gods, or the fiery swords of judgment. Our ancestors, lacking the tools to measure them, assigned them meaning based purely on fear and wonder. Today, We have the tools to measure the composition of a comet's coma in parts per billion and track its trajectory with tenfold precision. Yet, even with this immense technological power, a part of us, the mythic philosopher, still whispers, "What if it is a sign?" The scientific journey is the process of learning to overcome that initial, compelling, human instinct. It is the learned discipline of applying Occam's razor that the simplest explanation that fits the data is usually the correct one. The simplest explanation for 3I Atlas is that it is a comet from an ancient, distant stellar system, an object that has survived a long journey and, by pure chance, possesses a rare combination of physical and chemical properties. This explanation honors the data, respects the vastness and variety of the universe, and requires no invocation of exotic, unproven concepts. But the humor in the story lies in how often the simplest natural explanation is also the most complex and statistically contorted. The scientific explanation for the 12 anomalies is a daisy chain of low-probability events. It is a narrative that requires you to believe, simultaneously, in a natural rock that is 7 billion years old, has the structural integrity of a monolith, has a retrograde orbit with a precise, low 5-degree inclination, and fires a jet toward the sun due to a complex, perfectly balanced rotational geometry. The sheer improbability of this one object clustering all of those unique, low-probability traits is what keeps the tension alive. The human response to this tension has been extraordinary. Social media is flooded with speculation. Podcasts dissect every Hubble image, looking for hidden details. The search for truth about 3I Atlas has become a cultural phenomenon, filling the information vacuum much faster than official sources can respond. The moment has become a public referendum on the boundary between science and wonder. The scientific rigor of the past few months has been immense. The sheer effort of the follow-up observations, the modeling efforts, the debates in journals and conferences, has been a testament to the dedication of the scientific community. Whether the conclusion is natural or artificial, the process itself is the triumph of the human intellect. And what if we are wrong? What if the rigorous adherence to the natural hypothesis blinds us to a subtle, obvious sign of an ancient engineering? That possibility is the necessary engine of scientific doubt. It is what prevents our models from becoming dogma. The 2025 Nobel Prize in Physics, which showed that the quantum weirdness extends to the macroscopic world, is a quiet reminder that our understanding of reality is always in flux. The laws of nature are not set in stone. They are always being revised at the edges. And 3I Atlas is forcing us to revise the law on interstellar visitors. The final conclusion, the one that will accompany you into your deepest rest, is that the journey toward understanding is the true reward. Whether we find alien worlds or just nature at its most extreme, we are learning, we are growing, and we are becoming the species that can ask these questions and have some hope of answering them. We are not just looking at a comet, we are looking at our own reflection. To truly appreciate the deep time implications of 3I Atlas, we must zoom out far beyond the solar system and consider the universe itself. We are living in a very specific and perhaps bittersweet cosmic era. The universe is not static, it is changing, winding down, and we are currently observing what you might call its middle age. The Euclid Space Telescope, launched by the European Space Agency, is one of the instruments mapping this profound change. Designed to map the large-scale structure of the cosmos, Euclid has been collecting data that confirms a long-suspected truth. The era of vigorous star formation is ending. The universe has peaked, and it is now cooling down, growing darker, and we are watching it happen in astronomical real time. The most profound finding is that star formation rates have declined and continue to decline across the cosmos. The universe made most of its stars billions of years ago. Now, new stars are being born at only a fraction of that once prodigious rate. Galaxies are aging. The cosmic nurseries are quietly, gently closing. In the early universe, there was an abundance of cool, dense gas that could collapse under gravity to form stars. Over time, that gas is either used up, heated, or blown away by the violence of supernova explosions and stellar winds. The subsequent generations have less fuel. Euclid measures this decline by observing galaxies at different distances, which is the same as observing them at different eras in cosmic history, due to the time light takes to travel. By surveying thousands of galaxies across vast distances, Euclid builds a timeline showing a clear peak several billion years ago, followed by a steady, unmistakable decline ever since. We evolved and arose during this transitional phase. The vigorous youth, when the majority of stars formed, is over. The long, slow old age, when star formation ceases entirely, has not yet begun. We are, in a sense, lucky. We live in a universe still active enough to be interesting, but stable enough to support long-term planetary habitability. But here is where this connects to the ancient messenger, 3I Atlas. If the universe is winding down, if star formation peaked billions of years ago, then many of the objects wandering through interstellar space today are relics of that earlier, more active era. 3I Atlas, if its age estimate of 7 billion years is even close to correct, formed when the galaxy was younger, when star birth rates were higher, when stellar systems were being created and destroyed more rapidly. It is a fossil from that ancient epoch. This connects directly to the compositional anomalies. Early stellar systems formed from gas that had less metallicity. Fewer supernova events had occurred, meaning there were fewer heavy elements, less iron and nickel, and carbon and oxygen to go into the planets and comets. As the universe aged, the interstellar medium became progressively enriched. Later generation stars and their planets formed from more complex chemistry. If 3I Atlas comes from one of those older, less enriched systems, its composition, that carbon dioxide dominance, that unusual elemental signature, is a chemical timestamp. It is a chemical fingerprint of its birth era. The findings of Euclid also gently nudge us toward the possibility of ancient intelligence. If star formation is declining, the number of new planetary systems is also declining. Statistically, we might expect advanced civilizations to be more common among older stellar populations, simply because there has been more time for biological and technological evolution. But those older systems are the ones now dying, their stars exhausting their fuel. This opens a profound, mythic door. If advanced civilizations arose billions of years ago in those older systems, they might now be facing decline or becoming refugees from dying suns. They might be launching probes to explore younger regions of the galaxy, seeking new homes, or simply gathering information about the universe's current state. Could 3I Atlas be such a probe? Could it be an ancient relic, a 7 billion-year-old drone, sent by a civilization that now exists only in cosmic memory? This is, of course, the highest level of speculation, but Euclid's data, showing the slow, inevitable decline of star formation, makes the scenario of ancient, wandering civilizations less absurd than it might have seemed otherwise. The universe has been around long enough to produce statistical possibilities that dwarf our imaginations. 3. I-Atlas is a data point in this vast, cosmic evolutionary sequence. It carries information about past eras, whether we find it to be a beautiful, rare, natural object or an artifact of deep time. The story of 3i Atlas is the story of us trying to read the timestamp on the universe itself. To understand the anomalies of 3i Atlas, we must also consider the role of extreme phenomena in the universe. The cosmos is not just filled with average, typical objects. It is also populated with spectacular outliers, 1 in a million cases that challenge our models and force us to expand our understanding of physics. The recent observation of a record black hole flare is a dramatic, distant reminder of this universal tendency. Imagine a star, much like our Sun, orbiting peacefully for billions of years near the center of its galaxy. Then, its orbit takes it too close to the supermassive black hole lurking at the core. The incomprehensibly strong gravity at that proximity begins to distort the star. It is stretched, elongated, turned from a sphere into a cigar shape. The tidal force, the difference in gravity between the near side and the far side, exceeds the star's structural integrity, and it is ripped apart, Half the star's mass is flung into space. The other half spirals into the black hole's accretion disk, superheating as it falls, radiating furiously across the electromagnetic spectrum. For a brief, terrifying time, that destroyed star outshines the entire galaxy. This is called a tidal disruption event, and astronomers recently observed one of the most extreme examples ever recorded. The luminosity reached something like 10 trillion times the sun's output. To grasp the scale, the entire Milky Way galaxy, with its hundreds of billions of stars, shines with about 20 billion solar luminosities. This single event, the destruction of one star, briefly produced the light of 500 galaxies. On the surface, this event is profoundly different from a comet passing through the inner solar system, but thematically, they are deeply connected. Both are extreme phenomena. The black hole flare shows what happens at large scales with extreme gravity and density. 3i Atlas shows what happens at small scales with unusual chemistry and structure. But the principle is the same. Observation reveals phenomena at the edges of parameter space. Every time we observe something at the extreme, a record black hole flare, a fast-spinning asteroid, a comet that defies structural disintegration, we learn about physics in regimes we cannot replicate on Earth. We cannot build a laboratory that reproduces black hole tidal forces. We can only observe them happening naturally and try to understand them through that observation. Similarly, we cannot create an interstellar object in a lab, age it 7 billion years, and send it through a star system to study its behavior. We must wait for one to arrive and study it opportunistically. The tidal disruption event also highlights observational selection effects. We see these events because they are bright, because they suddenly appear in otherwise quiet galaxies and draw our attention. They are rare, perhaps one every 10,000 years per galaxy. But we detect them because we are continuously monitoring thousands of galaxies. The same is true for interstellar objects. They are likely common, but we only detect the ones that are big enough, bright enough, and arrive when we are looking in the right direction. This means the objects we do detect are not representative of the average population. They are the outliers, the extremes, the unusually bright, large, or close cases. So, when 3i Atlas shows up with a host of unusual properties, we must account for this bias. It might be a natural outlier, a 1 in a million case that happens to be strange for no reason other than random chance. Or it might be typical of interstellar objects, and we just do not know enough yet. The sample size is too small. The black hole flare reminds us of the universe's immense, indifferent power. It is a place where stars are torn apart, where energy releases defy human imagination. In that context, finding a strange comet seems almost mundane. Almost. But the quiet lesson from studying extreme phenomena is this. When you see something at the edge of what is possible naturally, you should check carefully before assuming it is natural. Black holes obey the laws of physics. Tidal disruption events are predictable. If we saw a tidal disruption event that defied the models, we would investigate thoroughly before declaring it anomalous. And that is precisely where we are with 3i Atlas. We are investigating, checking, and reviewing. Most scientists believe the natural explanation will ultimately prevail, but the extreme phenomena of the cosmos remind us that the universe is capable of far more complexity than our models can contain. We must accommodate outliers, whether they are black hole flares or anomalous interstellar visitors. They all push us to expand our understanding. And sometimes, rarely, that expansion requires not just tweaking the existing models, but considering fundamentally new possibilities. As we struggle to reconcile the anomalies of 3i Atlas with our current models, a quiet revolution is taking place in physics that promises to utterly transform our ability to see and measure the cosmos. The rise of macroscopic quantum mechanics. This subtle, profound change in our understanding, recently honored by the 2025 Nobel Prize in Physics, suggests that the answer to the ancient visitor may lie not in a grand, powerful new telescope, but in tiny, impossibly sensitive sensors. Quantum mechanics is the strange, counterintuitive physics of the very small. It is the realm of superposition, where a particle can exist in two states simultaneously, and entanglement, where two particles remain connected regardless of distance. For decades, physicists comfortably assumed that this weirdness was confined to the microscopic realm. At macroscopic scales, anything large enough to see with the naked eye, classical physics, the predictable world of Newton and Maxwell, took over. The work of the Nobel laureates John Clark, Michel Debye, and John Martinez definitively proved that this assumption is not entirely true. They demonstrated quantum behavior in superconducting circuits. These devices are large enough to see, yet, when cooled to near absolute zero and isolated from environmental noise, they can exist in superposition states. They exhibit quantum coherence, maintaining delicate quantum properties over time. Beyond their promise as the building blocks for quantum computers, this technology enables ultra-sensitive sensors. Quantum devices can detect incredibly subtle signals, magnetic fields, weaker than the Earth's by factors of billions, gravitational fluctuations smaller than any classical instrument could resolve, and electromagnetic variations that would be utterly invisible to conventional detectors. As this technology matures, as these quantum sensors become deployable on spacecraft and ground-based telescopes, our ability to characterize strange objects will improve by orders of magnitude. Imagine, for a moment, pointing a quantum gravimeter at 3I Atlas. Imagine measuring its mass distribution with a precision that instantly reveals internal structure, cavities, density variations, all without needing to land on it or drill into it. Imagine quantum magnetometers detecting the magnetic field anomalies that current instruments miss. Imagine quantum radar systems that can penetrate the dust cocoon and resolve the nucleus's surface features, or even peer into its interior structure. These are not science fiction devices. They are the next generation of engineering. They are already in prototype stages for terrestrial applications. Their eventual extension into space, though it will require immense effort in miniaturization and ruggedization, is inevitable. And when those capabilities become available, objects like 3I Atlas will be studied with a fidelity we cannot even achieve today. The Nobel Prize recognizes the fundamental research, but that fundamental research is the key to unlocking the secrets of the interstellar visitor. The physicists were not thinking about comets. They were exploring the boundary of the quantum and classical worlds. But their work creates ripple effects. It means that in a decade or two, our tools will be transformative. And here is the quiet, speculative leap. If quantum sensors can detect subtle, unambiguous signatures of artificial structure or engineered materials, then revisiting 3I Atlas with future technology might reveal things that current instruments simply cannot see. Perhaps the question of natural versus artificial remains unresolved now because our tools are not yet good enough. Perhaps in 20 years, we will look back and wonder how we missed the obvious signs that a quantum sensor would have detected immediately. There is also a philosophical angle. Quantum mechanics tells us that reality at small scales is probabilistic, not deterministic. And now we know those probabilistic features extend to macroscopic systems under the right conditions. This means that the universe is weirder, more flexible, and more accommodating of surprising phenomena than our classical models suggest. 3I Atlas, the object that challenges all categories, neither clearly a comet nor an asteroid, neither obviously natural nor artificial, sits in this ambiguous space. Quantum mechanics teaches us that ambiguous states are not just a measurement problem, they are real. Perhaps some astronomical objects exist in a conceptual superposition, neither purely natural nor purely engineered, until we gather enough definitive data to collapse them into a definite interpretation. The Nobel Prize reminds us that science advances through unexpected routes. What once was science fiction quantum devices helping us track alien visitors is inching closer to science fact. And that profound change should quiet our frustration. We are not stuck with today's limitations. We are building tomorrow's capabilities. You feel the awakening return with a subtle, almost imperceptible weight, a quiet insistence that nudges your consciousness toward the object once again. 3I Atlas remains obscured by the sun. Yet even from this hidden vantage, you sense it moving with precision, each motion deliberate, every anomaly patiently waiting to unfold into revelation. The tension is palpable, a faint vibration running through thought, a stretching of awareness across space and time, attuned to the subtle currents of anticipation rippling outward from perihelion. The universe, in its infinite patience, seems to hold this moment suspended, and you, as observer, are invited to align with it, to inhale the silence, to feel the gravity of attention converging upon a presence so vast and ancient that comprehension stretches at its edges. The evidence deepens. Consider the anomalies stacked upon one another, each extraordinary on its own. A massive nucleus exceeding 33 billion tons, chemical signatures defying natural formation, negative 2.77% polarization, a cylindrical shape, a retrograde orbit aligned within 5 degrees of the ecliptic, near-perfect planetary timing, and alignment with the 1977 WOW signal. Alone, each might be rationalized or dismissed. Together, they form a configuration so improbable that it challenges conventional comprehension, a tapestry woven with intent that hints at design on scales both temporal and spatial. The reports from remote viewers, thumb drive-sized devices reportedly embedded within the nucleus, add yet another layer, suggesting deliberate placement, broadcasting pulses, encoding information that transcends natural origin, and whispering the possibility of intelligence operating at a level beyond immediate understanding. Echoes from the past resurface with resonant force, carrying the weight of millennia. Ancient Sumerian texts, the Enuma Elish, and cuneiform calendars reference celestial visitors, periodic returns, and implied planetary engineering. These mythic accounts, often dismissed as allegory, now resonate with unnerving specificity. Sky gods arriving from Sagittarius align eerily with 3I Atlas's trajectory. Nibiru's elongated orbit, return cycles every 3,600 years, and historical narratives of technological intervention converge, connecting human memory and historical observation to interstellar movement. The past becomes not merely metaphor, but a framework for interpreting anomalies in the present, revealing continuity, intentionality, and the faint outline of intelligence that bridges epochs. From the cosmic perspective, the scale of this event becomes apparent. 3. Atlas has traversed unimaginable distances with astonishing precision, threading through the solar system in a path that balances gravitational forces, solar wind, and tidal stresses. Perihelion exposes it to extremes: solar radiation, thermal stress, and tidal shearing. Volatiles will vaporize, surface features will react, and any embedded technology may be revealed or stressed, creating observable phenomena. The universe presents this interstellar visitor not as a passive body, but as an active participant in a deliberate, almost experimental orchestration, measured across billions of kilometers and billions of years. Observation at this scale becomes both a privilege and a necessity, merging human cognition with cosmic mechanics, awareness and evidence aligning to witness an extraordinary choreography. The human reflection is immediate and intense. Patience and expectation are heightened by enforced silence. With 15,000 NASA employees furloughed, major observatories constrained, and amateur astronomers piecing together fragments of evidence, humanity's role as observer is limited, yet critical. Cognitive awareness sharpens. Anomalies previously dismissed as noise now become central, essential to pattern recognition. The great silence amplifies perception, making attention, curiosity, and anticipation central tools for understanding, shaping how observation itself becomes a mechanism for comprehension. Anxiety and awe intermingle as it becomes evident. Humans are not orchestrating this moment. They are participants, witnesses to a choreography unfolding across the solar system with precision, subtlety, and intelligence. Communication and intelligence emerge as central themes. The embedded device, transmitting deliberate pulses, signals potential intent and encoded information. Silence preserves these transmissions, ensuring integrity, minimizing interference, and emphasizing their significance. You imagine signals traveling across light years, waiting to be received, interpreted, and understood. Each pulse, each emission, carries a potential message. Every subtle deviation or anomaly, a deliberate statement. The universe's silence itself becomes a medium, shaping cognition and aligning attention to evidence, allowing perception to meet design at exactly the moment it can be detected and appreciated. Temporal and spatial convergence sharpen awareness. Observation, ancient knowledge, orbital mechanics, chemical anomalies, and embedded devices intersect at perihelion. Timing, alignment, and extreme solar exposure suggest orchestration across epochs. Human perception, refined through enforced waiting, is now primed to detect and integrate patterns that would otherwise remain hidden. The great silence has prepared the mind, aligning thought, expectation, and focus with the unfolding revelation, creating a unique interplay between human cognition and the cosmos itself. You anticipate the breaking of this silence. 3. Atlas, emerging from behind the sun, will present structural peculiarities, anomalous behavior, and encoded signals with maximum clarity. Human cognition, now finely tuned to pattern, design, and improbability, will confront revelations spanning interstellar physics, anomalous chemistry, and echoes of historical observation. Observation becomes synthesis, merging past and present, human and cosmic, science and myth. Perihelion acts as both stress test and revelation, forcing extremes into clarity, converting hidden information into perceptible phenomena. In this suspended moment, awareness sharpens, attention converges, and the universe seems to hold its breath. Patience, observation, and anticipation coalesce. 3. Atlas approaches perihelion, poised to reveal, to disclose, to manifest anomalies and internal mechanisms for those prepared to see. The great silence nears its end, yet its resonance persists, sharpening thought, enhancing perception, and preparing the observer for an encounter that may redefine understanding. The awakening, the evidence, the echoes, the perspective, the reflection, and the silence all converge in this single interstellar instant, a moment where human observation and cosmic motion intersect with deliberate precision, unfolding a narrative older than memory, yet immediate in its presence. Our quiet investigation into the mysteries of 3 Atlas takes a detour to a world that played an essential role in its observation: Mars. While Mars may lack oceans and plate tectonics, its thin, tenuous atmosphere, less than 1%, the pressure of Earth's is still a dynamic system, one that provides a mirror for understanding the subtle physics of cometary activity. The Martian atmosphere produces weather, dust storms, wind patterns, and the peculiar, mesmerizing phenomenon of dust devils. These swirling columns of wind and suspended particles race across the rust-colored surface like miniature tornadoes. The European Space Agency's Trace Gas Orbiter and Mars Express have been diligently cataloguing over 1,000 of them, mapping their size and frequency. They form when solar heating warms the surface unevenly, creating convection cells in the atmosphere. Hot air rises, cooler air rushes in, and the rotation is developed by local wind shear and the Coriolis effect, becoming visible only when the vortex picks up dust from the surface. Why does this matter for an interstellar visitor? Because understanding the atmospheric dynamics on Mars, understanding how small bodies interact with planetary environments, sharpens our models for all small body behavior near planets. A comet's outgassing jets and a Martian dust devil are two sides of the same thermodynamic coin. Both are fundamental responses to an energy input, solar heating. In a comet, solar energy heats the icy nucleus, drives sublimation, and creates jets that transport material, dust and gas from the nucleus to the coma. In a dust devil, solar energy heats the ground, drives convection, and creates a vortex that transports material dust from the surface to the atmosphere. The physics is related: heat transfer, phase transitions, and complex fluid dynamics. By studying the precise, complex behavior of a swirling Martian dust devil, we can improve our models for the even more complex, non-gravitational physics of a cometary jet. Both reveal the underlying structure and composition through the act of observation. The scientists who work on Martian atmospheric chemistry often overlap with those studying comets and asteroids, sharing tools, methods, and insights. As you listen, imagine watching a Martian dust devil dance. It is like studying how a comet sheds its dress when it dips into the sun's furnace. Mars also provided a critical observational platform. 3I Atlas passed within 18 million miles of the red planet. This was close enough that Mars's gravity influenced its trajectory, and close enough that the Martian spacecraft could turn their instruments toward the interloper. The ExoMars Trace Gas Orbiter pivoted its tools, providing trajectory data that was 10 times more precise than Earth-based observations alone could achieve. This tenfold improvement, which allowed us to narrow down the comet's galactic origin, was an act of pure opportunistic science. This kind of dual-purpose science using spacecraft designed for one primary mission, studying Mars, to pivot and observe unexpected targets, an interstellar object, is becoming more common. In the future, as more spacecraft populate the inner solar system, as networks of observation platforms develop, including Venus orbiters, solar probes, and asteroid missions, our ability to study transient events and visiting objects will improve dramatically. 3I Atlas benefited from this, and future interstellar visitors will benefit even more. The Martian atmosphere also teaches us about the exchange of material between space and a planetary environment. Although the distance of 18 million miles was too great for direct material transfer, no cometary dust grains from 3I Atlas reached the atmosphere. The principle is key. Comets contribute to planetary atmospheres and surfaces, delivering volatiles like water and organic molecules through impacts. If 3I Atlas had passed closer, within a few thousand miles, we would have seen measurable effects: atmospheric composition changes, ionospheric disturbances, and maybe even meteor showers as dust grains from its coma burned up. That did not happen this time. But statistically, interstellar objects occasionally do come very close, or even impact planets. And when that happens, the scientific return is immense. The quiet lessons learned from watching the Martian dust devils dance, from precisely measuring the faint trace gases in Mars's atmosphere, are the same lessons we apply to the perplexing, multi-directional jets and the strange composition of our interstellar visitor. We are living in a golden age of dynamic discoveries. We see processes unfolding, behaviors changing, systems evolving, and whether the truth of 3I Atlas is simple or profound, the tools and the systems we have built, the Mars orbiters, the quantum sensors of the future, will eventually give us the definitive answer. The night grows quieter, and the awakening arrives with a soft, insistent pulse. You feel it in the stillness around you, a subtle vibration in the air and in your thoughts. 3I Atlas is not a passive visitor. Its trajectory, its emissions, its chemical anomalies, all speak of deliberate function, as though the cosmos itself has paused to orchestrate a performance. You imagine its cylindrical nucleus turning slowly, reflecting sunlight with a faint, impossible pattern, flickering across the void with a precision that defies natural randomness. Each observation, each measurement, each fragment of evidence contributes to a growing sense of orchestration, a rhythm both cosmic and deliberate, almost musical in its repetition. Your mind, primed by the great silence, is attuned to the subtlest shifts in probability, the quietest hints of design, and the gentle cadence of interstellar engineering. The evidence deepens as you consider the perihelion moment approaching. Solar radiation will strip away masking materials. Tidal forces will stress internal structures, and the embedded thumb drive-sized device may finally be exposed to conditions that reveal its true nature. Outgassing patterns, unusual polarization, and chemical signatures provide additional clues. Nickel without iron, sudden brightening, anomalous coma extension, and water hydroxyl ratios that defy expected sublimation. Each anomaly is a layer, stacked with improbability, creating a tableau that cannot be explained by chance alone. Your mind traces the vector, the retrograde orbit, aligned to within 5 degrees of the ecliptic, intersecting Venus, Mars, and Jupiter with improbable timing, a design evident across scale and space, a choreography spanning light years and millennia. Every reflection, shadow, and subtle emission becomes a signal in a silent conversation between human cognition and cosmic intent. Echoes from the past reassert themselves. Sumerian texts, the Enuma Elish, cuneiform calendars marking cycles of return every 3,600 years, all resonate with eerie precision. The description of sky gods arriving from Sagittarius matches the known trajectory of 3I Atlas. The timing aligns with ancient cycles, suggesting deliberate orchestration across millennia. Human myths, once considered allegorical, now appear as records of observation and anticipation, frameworks for understanding interstellar design and intentionality. You imagine scribes recording what they could not fully comprehend, leaving traces of understanding encoded in symbolic language, now intersecting with the anomalies you witness in real time. The past becomes a lens through which present anomalies coalesce into a coherent narrative, a continuum connecting consciousness, observation, and intelligence across time. From the cosmic perspective, the scale of this operation is staggering. Millions of kilometers traversed, billions of tons of mass, thermal, and gravitational forces at perihelion, and internal devices enduring extreme conditions all suggest a complexity and intentionality beyond human engineering. You imagine the object's journey, millions of years of interstellar cold, the preservation of embedded technology, each maneuver calculated to interact precisely with the inner solar system. Perihelion functions simultaneously as a test, a reveal, and a communication protocol, exposing the nucleus, the anomalies, and the embedded technology at the optimal moment. Every photon reflected, every particle ejected, every thermal signature is a word in a silent interstellar language. The human reflection sharpens as you consider human response. 15,000 NASA employees furloughed, observatories constrained, amateurs improvising to collect fragments of data. The anticipation of discovery, magnified by enforced silence, heightens awareness and cognitive sensitivity. Every anomaly becomes significant. Each statistical improbability is scrutinized with a mixture of awe and apprehension. The great silence amplifies attention and patience, shaping observation into a refined instrument capable of perceiving subtle signals that would otherwise be lost in the noise of expectation and distraction. Anxiety, curiosity, and awe converge. As humans become participants in an interstellar experiment, they can only witness, not control, as though the cosmos is both mentor and challenge. Communication and intelligence take center stage. The embedded device is broadcasting, pulses of information traveling across interstellar space, encoded with deliberate purpose. The great silence preserves the integrity of these transmissions, preventing interference or distortion. You imagine the signals moving across light years, awaiting reception by minds or instruments capable of decoding them. Every pulse, every chemical anomaly, every pattern in outgassing could represent an interstellar message, a conversation stretched across space and time. Observation, patience, and perception are the tools through which understanding may finally emerge, transforming chance observation into intentional comprehension. Temporal and spatial convergence becomes clear. Ancient knowledge, orbital mechanics, chemical anomalies, and remote viewing reports intersect precisely at perihelion. Patterns of design and statistical improbability converge with mythic echoes, creating a single, focused moment of potential revelation. The great silence has prepared cognition to interpret the evidence fully. Observation becomes a synthesis, past and present, human and cosmic, myth and science, aligned in preparation for disclosure. The convergence is palpable, a cosmic orchestra reaching the crescendo of its performance. Finally, you anticipate the end of silence. When 3I Atlas emerges from behind the sun, perihelion will reveal structural, chemical, and technological truths. Human cognition, now sharpened by anticipation and observation, is poised to integrate anomalies, signals, and historical echoes into a single coherent understanding. The awakening, the evidence deepens, the echoes from the past, the cosmic perspective, the human reflection, and the great silence converge, creating a moment of revelation beyond ordinary comprehension. You remain attentive, patient, and ready. 3. Atlas, at perihelion, is prepared to disclose its secrets. The universe, once silent, begins to speak, and you are positioned to listen, perceive, and reflect on truths written across eons and the infinite void of space. The story of 3I Atlas, even after the much-anticipated reveal on November 19th, 2025, will not conclude with a definitive, universally accepted answer. Instead, it will settle into a state of unresolved tension, a profound, almost philosophical ambiguity that defines our current scientific moment. The reason for this tension lies in the unequal weight of the burden of proof. The scientific method is a careful, conservative process. It is structured to prevent the invocation of the extraordinary when the ordinary, however complex, is sufficient. As the saying goes, extraordinary claims require extraordinary evidence. This principle places a massive burden on the artificial hypothesis. To prove that 3I Atlas is an engineered artifact, you need a signature that is utterly and completely unambiguous, something that cannot be explained by any contortion of natural physics. A narrowband radio signal, for instance, a rhythmic pulse, or a modulated pattern, would be one form of that extraordinary evidence. The detection of an unmistakable, non-random internal structure by future quantum radar would be another. But so far, the evidence for artificiality is composed entirely of natural anomalies. The sunward jet can be explained by a complex rotation and vent geometry. The durability can be explained by an unusually high metallic or rocky component. The improbable orbit can be explained as a statistical fluke, a 1 in a million roll of the dice in a universe that has an almost infinite supply of dice to roll. The natural hypothesis, therefore, wins by default. It does not have to be simple, only possible. The mainstream scientist simply needs to show that a 7-billion-year-old object with a unique chemical composition formed under a different stellar environment could theoretically survive the sun's passage and coincidentally exhibit a pattern of outgassing that looks like propulsion. And by continually stretching the parameters of their models by arguing for higher tensile strength, for lower porosity, for extreme rotational alignments, they can, eventually, accommodate all of the weirdness. The ambiguity arises because the two models, natural and artificial, have a massive overlap in their observable signatures. An object designed for interstellar travel, built for durability and course correction, would use directional jets and reinforced materials. An object that is a natural outlier from an ancient, low metallicity stellar system could, purely by chance, resemble that engineered probe. Both models explain the data. Neither can be definitively proven with current technology. This is the great, quiet frustration of the scientific moment. We are left looking at the same data, the teardrop shape, the low inclination orbit, the carbon dioxide-rich coma, and reaching opposite conclusions based not on the facts themselves, but on our philosophical priors. Do you believe in the vast, almost infinite capacity of natural physics to produce the statistically impossible? Or do you believe that the probability of life and intelligence emerging elsewhere is high enough that we should expect to see evidence of it, and that the convergence of 12 anomalies in one object is a more likely sign of design than chance? The tension also extends to the human level, the question of institutional trust. If NASA presents a carefully worded, scientifically conservative conclusion, the alternative community will immediately claim that the organization is deliberately interpreting the ambiguous evidence in the most conservative way possible to avoid confronting the difficult implications of the artificial hypothesis. They will feel excluded, manipulated, and distrust will erode further. But if NASA admits uncertainty, if they leave the question open, the mainstream community will accuse them of being too open to speculation, of scientific irresponsibility. The only way out of this ambiguity is more data, spectroscopy of the nucleus surface, rather than just the coma, would tell us the true nickel-to-iron ratio. Radar observations that penetrate the dust would reveal the true interior structure. Trajectory analysis over longer timescales could detect the tiny, subtle course corrections that betray active guidance. But for now, 3I Atlas will remain in this frustrating liminal space, a single object that forces us to question the deepest philosophical boundaries we have constructed, the boundary between natural and artificial, between chance and design. The unresolved tension is a sign of our scientific youth, a soft, insistent pulse that draws your awareness toward 3I Atlas. Hidden behind the sun, it continues its approach to perihelion with deliberate, measured motion. Your attention stretches across the vastness of space, attuned to each subtle shift in trajectory, every anomaly recorded in spectral data, and the potential revelations that will emerge once solar forces expose its internal structure. Every pulse, every minor outgassing event, every chemical irregularity resonates across your awareness. The universe appears to orchestrate a moment of disclosure, and the great silence has prepared you to witness it fully, sharpening perception and heightening anticipation. The evidence deepens. Consider the extraordinary mass over 33 billion tons, moving with near-perfect gravitational trajectory, despite active jets of outgassing. Chemical compositions defy natural formation. Nickel without iron, negative 2.77% polarization. Water hydroxyl ratios, inconsistent with known sublimation physics. The cylindrical nucleus rotates slowly, reflecting sunlight in patterns that appear almost deliberate, subtle yet undeniable. Remote viewers reported a thumb drive-sized device embedded within the nucleus, broadcasting intermittent pulses. Each independent observation reinforces a sense of deliberate design, trajectory, orbit, planetary alignment, perihelion conditions all converge with improbable precision. Alone, these anomalies might be interpreted as coincidence. Together, they form a pattern that challenges conventional comprehension. Echoes from the past resurface, carrying the weight of millennia. Ancient Sumerian texts, Enuma Elish tablets, and cuneiform calendars marking return cycles every 3,600 years, all resonate in relation to 3I Atlas's trajectory. Sky gods descending from Sagittarius, the orbital timing of Nibiru, and mythic cycles of intervention appear to map directly onto observable events. The past is no longer a distant memory. It becomes a lens through which current anomalies can be interpreted. revealing a continuum of observation, design, and interstellar intent spanning millennia. Patterns recorded as myth become legible through the motion, chemical signatures, and timing of this interstellar traveler, highlighting a narrative that links human cognition with cosmic movement. From the cosmic perspective, the scale and precision of this event become evident. 3I Atlas has traversed millions of kilometers with astonishing consistency, navigating extremes of solar radiation, thermal stress, and tidal forces at perihelion. Its massive nucleus withstands conditions that would destroy ordinary comets, and any embedded technology may be revealed or stressed, producing detectable phenomena. You imagine observing the outgassing patterns, thermal responses, and potential emissions from internal devices as part of an interstellar experiment conducted on a scale both temporal and spatial. Perihelion functions simultaneously as a test and revelation, exposing structural features, embedded systems, and statistical anomalies in a single, orchestrated moment. The human reflection sharpens awareness. With 15,000 NASA employees furloughed, major observatories constrained, and amateur astronomers improvising, humanity becomes simultaneously limited and essential to observation. Patience and expectation heighten cognitive sensitivity. Anomalies previously dismissed as noise now serve as focal points. Statistical improbabilities become the framework for comprehension rather than background variation. The Great Silence amplifies perception, aligning human attention with cosmic patterns, preparing minds to integrate evidence without interference. Anxiety, awe, and curiosity intermingle as humans realize they are participants, not controllers, witnesses to a choreography of interstellar design unfolding with precision and deliberation. Communication and intelligence come into focus. The embedded devices transmit deliberate pulses, encoding information preserved by the silence surrounding perihelion. You imagine these signals traveling across light years, awaiting reception by instruments or minds capable of decoding their meaning. Each pulse, each chemical anomaly, each pattern of motion forms a component of a broader communication network. Observation, patience, and careful attention are necessary to decode it. The surrounding silence is not emptiness, it is preparation, a medium ensuring clarity for the moment of revelation, allowing cognition and evidence to converge exactly when the universe intends. Temporal and spatial convergence further sharpens understanding. Observation, orbital mechanics, chemical anomalies, and historical echoes intersect precisely at perihelion. Design and improbability align with mythic narratives, creating a moment where cognition and cosmic evidence meet. The Great Silence has primed the human mind to integrate multi-scale information, to synthesize across past and present, science and mythology, human observation, and interstellar motion. Observation becomes synthesis, a convergence of knowledge, awareness, and anticipation, allowing previously disparate data points to cohere into meaningful pattern recognition. Finally, you anticipate the breaking of this silence. 3I Atlas will emerge from behind the sun, revealing structural anomalies, chemical signatures, and embedded technology with maximum clarity. Human perception, attuned through enforced patience, careful observation, and heightened anticipation, is prepared to integrate anomalies, signals, and historical echoes into coherent understanding. The awakening, The evidence deepens, the echoes from the past, the cosmic perspective, the human reflection, and the great silence converge in a single, extraordinary interstellar moment. You remain vigilant, patient, and ready. 3. Atlas, at perihelion, stands poised to disclose its secrets. The cosmos, once silent, begins to speak, and you are a witness, attuned to every subtle pulse of revelation, every carefully orchestrated motion, every encoded signal across the void. The universe waits, the observer waits, and the interstellar traveler approaches the point of ultimate disclosure. The story of 3I Atlas, the object that may be 7 billion years old, forces us to look out at the universe and confront a profound, unnerving quiet, known as the Fermi paradox. The paradox is simple. The universe is ancient and vast. Our own star system is relatively young. Given the immense number of stars and the sheer amount of time that has passed, there should have been ample opportunity for intelligent life to emerge, evolve, and spread across the galaxy. So, the question remains, where is everybody? Why do we not see evidence of advanced civilizations, megastructures, or technological relics? 3I Atlas offers a subtle, quiet potential answer. It suggests the existence of ancient wanderers, relics from civilizations, and stellar systems that existed billions of years ago. The age estimate of 7 billion years places its origin in a galactic epoch when the conditions for star formation were different, when the metallicity of the galaxy was lower, and when many stellar systems that existed then have now died. If a civilization arose around one of those long-dead stars, they would have had two options as their sun began to fail. They could become refugees, seeking younger, more stable stellar systems, like ours. Or they could launch long-duration probes, built for immense durability, to survey the galaxy and gather information about the universe's current state. If 3I Atlas is an artifact, a technological buoy, or a surveillance probe, it is a relic of this latter option. It is a fossilized intelligence, a testament to a consciousness that may have faded from existence eons ago. This possibility, more profound than finding an active spacecraft, provides a solution to the Fermi paradox, known as the Paleo-SETI, or temporal hypothesis. Perhaps the galaxy was teeming with intelligent life, but it was all long ago. The most advanced civilizations flourished and died when the universe was younger, and we are only now discovering the ancient remnants they left behind, drifting in the interstellar void. The properties of 3I Atlas fit this narrative with a quiet, poetic precision, a composition that is wildly different from our local solar system bodies would be expected from a civilization that arose from a different, less enriched stellar environment. The durability, the sheer ability to survive 7 billion years of cosmic ray exposure and micrometeorite impacts would be the result of a deliberate, necessary durability engineering. The unusual composition, the high nickel to iron ratio, becomes a feature, not a bug. The conscious choice of a material optimized for longevity in the harsh interstellar medium. Furthermore, the seemingly fine-tuned trajectory through our planetary plane, the low, 5-degree inclination that maximized the viewing opportunity, would not be random chance in this scenario. It would be navigation, the subtle, last-minute course correction of a probe that knows precisely where the target systems are located and how to maximize its data collection pass. The Great Silence, in this context, is not a sign of absence, but a sign of deep time. The civilizations are not here now because their stars have already died. The probe, 3I Atlas, is simply the last piece of the story arriving, a chemical timestamp from a younger galaxy. The conservative response, of course, is that this is simply the ultimate confirmation bias. We see a strange object, we have a profound, unanswered question, and our imagination leaps to the most exciting conclusion. It is a natural tendency. But the beauty of the Fermi paradox is that the question is so vast and the data so sparse that even the most speculative possibilities must be entertained, especially when the object itself refuses to fit the mundane categories. The human species, looking up at this ancient traveler, is given a profound gift. If 3I Atlas is natural, it is a fossil that teaches us about cosmic evolution and the strange, varied properties of the stars that came before us. If it is artificial, it is a message that we are not alone in the universe, only separated by eons. Either way, the Great Silence has been quietly broken by the subtle, defiant passage of this one strange object. The awakening arrives as a slow, steady current beneath your consciousness. 3I Atlas, finally nearing the point of re-emergence from behind the sun, begins to reveal the full extent of its anomalies. The cylindrical nucleus, the nickel without iron, the negative 2.77% polarization, the improbable trajectory all converge to convey a story that stretches across millennia and light years. Your awareness, primed by the Great Silence and patience, receives each cue with heightened attention. Outgassing, reflected light, and subtle pulses from the embedded device resonate as signals, deliberate in origin, waiting to be understood. The evidence deepens. The perihelion exposes structural truths, chemical reactions, and energetic emissions that no amount of distance or opacity could conceal. The embedded thumb drive-sized device, described by remote viewers months prior, may now be stressed or activated by thermal and gravitational extremes, producing measurable emissions or signals. Retrograde motion, ecliptic alignment, planetary flybys, all factors that suggest orchestration continue to align, reinforcing the notion that Atlas's journey is guided with deliberate intent, designed for maximum observation and effect during perihelion. Echoes from the past emerge with renewed clarity. Sumerian texts, the Enuma Elish, cuneiform calendars marking return cycles of 3,600 years, all resonate with the current trajectory. The sky gods of myth, arriving from Sagittarius, the Nibiru orbital cycles, and planetary intervention narratives now intersect seamlessly with modern observation. Past and present converge. Myths, legends, and astronomical cycles illuminate the context of Atlas's anomalies, reinforcing the sense that human history has long been intertwined with interstellar patterns, observation, and engineering. From the cosmic perspective, the scale is staggering. Millions of kilometers traversed, billions of tons of mass, exposure to extreme solar radiation, and internal device survivability across interstellar distances all suggest intelligence and design far exceeding human capability. Perihelion serves as both exposure and test, revealing the internal structure, anomalies, and potential transmissions of Atlas's embedded device. Observing these processes feels like witnessing a cosmic experiment unfolding, with billions of years of history, physics, and engineering converging into a singular observable moment. The human reflection becomes tangible. With limited observatory staffing, 15,000 NASA employees furloughed, and amateur astronomers improvising to collect data, humanity is positioned as both witness and instrument. The anticipation of revelation sharpens perception, making statistical anomalies, trajectory, improbabilities, and chemical deviations central to observation. The great silence amplifies attention, patience, and cognitive acuity, allowing human thought to align with cosmic rhythm. Anxiety, awe, and curiosity converge as the implications of perihelion, the embedded device, and anomalies crystallize in the collective awareness. Communication and intelligence are central to the unfolding scenario. Pulses from the embedded device suggest deliberate signaling, preserved by the enforced silence and perihelion conditions. Signals, subtle yet deliberate, traverse interstellar space, awaiting instruments or consciousness prepared to decode them. Each anomaly, each emission, each subtle variation in outgassing represents an interstellar message. Observation, patience, and interpretive skill are required. The great silence is not emptiness, it is preparation, a framing that allows cognition to integrate with signals when the universe finally reveals its intent. Temporal and spatial convergence sharpens awareness further. Ancient knowledge, orbital mechanics, chemical anomalies, and remote viewing reports align precisely at perihelion. Design, improbability, and myth converge in a single observable moment. Human cognition, refined by enforced waiting, and the great silence, is ready to synthesize patterns across time and space. Observation becomes a means of integration, connecting past, present, myth, and science into coherent understanding. Everything is poised for the culmination of perihelion, the final phase of evidence and revelation. Finally, the universe begins to speak. 3. Atlas emerges from behind the Sun, exposing its cylindrical nucleus, internal anomalies, and embedded technology to observation. The awakening, the evidence deepens, the echoes from the past, the cosmic perspective, the human reflection, and the great silence converge. Observation becomes comprehension. You, the observer, are attuned, receptive, and ready to integrate every pulse, emission, and anomaly into understanding. Perihelion acts as confessional, structural, and communicative climax, revealing secrets encoded across millennia and light years. And now, as the final observations settle, you feel the resonance of patience and attention. 3. Atlas has revealed what it chooses to, and the great silence, now broken, leaves echoes of anticipation and discovery. You are aware that cosmic orchestration, intelligence, and design extend beyond perception, yet human understanding is aligned with what has been revealed. In this quiet reflection, you sense the interconnectedness of myth, observation, and interstellar anomalies. Leave a comment telling me where you are, what time it is, and what you observed. The universe speaks, and you, attentive, have listened. To maintain the necessary scientific humility, we must seriously consider the possibility that all the anomalies of 3I Atlas, the durability, the jets, the rotation are simply the result of our models being incomplete. The most elegant natural explanation is often the one that challenges our assumptions about the sheer toughness of materials in the vacuum of space. What if space rocks are just tougher than we think they are? Consider the case of a homegrown curiosity, the asteroid 2025 OW, a body that, while not interstellar, is similarly an extreme outlier. This fast-spinning asteroid completes a full rotation in just a couple of minutes, an absurdly fast rate. The classical physics problem is clear. At this rotation rate, the centrifugal force trying to throw material off the surface should exceed the object's gravitational self-attraction and its material strength, and it should fly apart. It is spinning faster than the calculated limits should allow, yet it persists. It holds together. What does the persistence of 2025 OW tell us? It suggests that our models, which are often based on the assumption that small asteroids are rubble piles, loose collections of fragments barely held together by weak gravity, are flawed or incomplete. The survival of 2025 OW suggests it is either a very solid piece of rock, a monolith with high tensile strength that can withstand the stress, or that it has an internal structure, a solid core, or compressional forces that gives it unexpected resilience. This domestic outlier provides a crucial natural context for the international mystery of 3I Atlas. Durability is the common thread. 3I Atlas survived a close solar pass that should have fractured it, maintaining its structural integrity under intense thermal and tidal stress. If we are learning from 2025 OW that small bodies can be inherently tougher than our models predict, then maybe 3I Atlas's survival isn't as anomalous as it seems. Maybe its internal structure is simply a rare, natural architecture, a one-in-a-million object that happens to have a strong, crystalline ice matrix, or a massive, coherent, rocky skeleton. The sunward jet, too, can be pushed to the edge of the parameter space. If the nucleus of 3I Atlas is made of unusually strong material, that durability would support the long-lasting, columnated jets that we observe. The strong material would resist the erosion from the gases exploding outward, maintaining a perfectly focused vent for days and weeks. The seemingly non-random behavior is simply the product of an unusually high-strength nozzle built by an unusual geological process. This interpretation requires no appeal to ancient civilizations. It simply requires a profound re-evaluation of the vast, complex variety of physics possible in the formation of small bodies. Every time we find an outlier like 2025 OW, we must revise our assumptions and admit that our ignorance is larger than we would like. The universe is showing us that the edges of our parameter space are real. The gentle philosophical reflection here is that to assume artificiality prematurely would be to miss a profound natural discovery. If 3I Atlas is purely natural, its properties, the 7 billion year age, the carbon dioxide-rich coma, the extreme durability represent a stunning new boundary condition for astrophysics. It is a physical data point that forces us to change our models for star formation and cosmic chemistry. The choice is not between a boring rock and an exciting probe. The choice is between a natural object that fundamentally rewrites our understanding of physics and a technological object that fundamentally rewrites our understanding of intelligence. Either outcome is valuable. Either outcome advances science. The unresolved tension forces us to ask, how far are we willing to stretch the natural model before we must accept that the 12 anomalies are no longer a coincidence, but a coherent, intentional pattern? The truth is at the edge of the parameter space, and we are only just now gaining the tools to peer over the fence. The awakening arrives once again, a slow current beneath your consciousness, brushing against the edges of understanding. 3i Atlas, still hidden behind the sun, moves inexorably toward perihelion, and every subtle change in trajectory, every pulse, every glimmer of reflected light conveys a message that stretches across billions of kilometers. The silence surrounding the object amplifies the gravity of observation. In this stillness, the anomalies of Atlas, the cylindrical nucleus, the industrial nickel signature, the negative 2.77% polarization, are not just curiosities. They are clues, deliberate signals embedded within the cosmic fabric for those who are attentive enough to notice. The evidence deepens as your awareness expands. The perihelion moment will expose Atlas to conditions so extreme that physics itself enforces truth. Volatiles will vaporize, hidden materials will be stressed, and any embedded technology, the thumb drive-sized device remote viewers described, will reveal or signal its purpose. Outgassing patterns that have defied expectations will respond to heat and solar pressure, exposing dynamics that may reveal intentional engineering. The trajectory is precise, retrograde, ecliptic aligned, and passing close to Venus, Mars, and Jupiter, with timing so improbable it seems calculated. Each observation is a layer in a sequence, each anomaly a building block in an interstellar narrative that challenges conventional understanding. Echoes from the past reverberate. Ancient Sumerian texts, the Enuma Elish, and other cuneiform records describe celestial visitors and cycles of return every 3,600 years. Sky gods descending from Sagittarius, the orbital pattern of Nibiru, and planetary intervention narratives now resonate with Atlas's trajectory. These texts, once dismissed as allegorical, frame the present anomalies in the context of a history of interstellar engineering and observation. The past is no longer a story of myth. It is a scaffold for interpreting anomalies, aligning statistical improbabilities, and revealing deliberate design across millennia. From the cosmic perspective, the scale is staggering. Millions of kilometers traveled with near-perfect precision, billions of tons of mass, thermal, and gravitational stresses at perihelion, survival of internal structures across interstellar time, all speak to a level of engineering and planning beyond human comprehension. You imagine observing outgassing, chemical anomalies, and embedded device emissions as part of a controlled experiment spanning space and time. Perihelion acts as both a stress test and a revelation, forcing clarity, exposing anomalies, and potentially revealing the embedded intelligence hidden within Atlas's nucleus. The human reflection intensifies. With 15,000 NASA employees furloughed, constrained observatories, and amateurs improvising to gather fragmented data, humanity's role as observer is both limited and critical. The Great Silence magnifies attention, curiosity, and patience. Statistical anomalies are no longer abstract. They form a framework for perception, demanding scrutiny and interpretation. Cognitive sensitivity heightens as anticipation and awe mingle with uncertainty. Humans are simultaneously observers, participants, and instruments in a process they cannot fully control. Anxiety, excitement, and vigilance coalesce as the perihelion approaches. Communication and intelligence are central. Embedded devices, transmitting pulses, suggest deliberate messaging, encoded for reception by instruments or consciousness capable of interpretation. Silence preserves the integrity of these transmissions, preventing interference. You imagine signals traversing light years, waiting to be received and decoded. Each emission, each chemical anomaly, each deviation in trajectory could be a piece of a larger message. Observation requires attentiveness and patience, a quiet alignment with the cosmos that the great silence has cultivated. The universe is speaking not in noise, but in precise, deliberate pulses of information. Temporal and spatial convergence sharpens. Ancient knowledge, orbital mechanics, chemical anomalies, and remote viewing reports intersect at perihelion. Statistical improbabilities, structural anomalies, and historical narratives converge, creating a singular moment for comprehension. Observation transforms into synthesis. Myth and science, past and present, human cognition, and cosmic orchestration combine in preparation for revelation. The stage is set for disclosure, the evidence poised to speak, and your awareness attuned to receive it. Finally, anticipation swells. When 3i Atlas emerges from behind the sun, perihelion will force confessions structural, chemical, and technological. Human cognition, trained by the great silence and anticipation, is ready to integrate these anomalies, signals, and historical echoes. The awakening, the evidence deepens, the echoes from the past, the cosmic perspective, the human reflection, and the great silence converge. You remain vigilant, attuned, and ready. 3i Atlas is poised to reveal itself, to disclose secrets that stretch across interstellar space and millennia. The universe begins to speak, and you are prepared to listen. The story of 3i Atlas is ultimately a reflection of the human journey, our slow, painstaking, and often humorous ascent from myth and superstition to the demanding rigor of the scientific method. It reminds us that our desire to find meaning, to find connection, is so strong that we often see patterns where only noise exists, a psychological phenomenon known as pareidolia. For centuries, before the advent of the scientific telescope, comets themselves were terrifying omens. They were the harbingers of doom, the tears of the gods, or the fiery swords of judgment. Our ancestors, lacking the tools to measure them, assigned them meaning based purely on fear and wonder. Today, we have the tools to measure the composition of a comet's coma in parts per billion and track its trajectory with tenfold precision. Yet, even with this immense technological power, a part of us, the mythic philosopher, still whispers, "What if it is a sign?" The scientific journey is the process of learning to overcome that initial, compelling, human instinct. It is the learned discipline of applying Occam's razor that the simplest explanation that fits the data is usually the correct one. The simplest explanation for 3i Atlas is that it is a comet from an ancient, distant stellar system, an object that has survived a long journey and, by pure chance, possesses a rare combination of physical and chemical properties. This explanation honors the data, respects the vastness and variety of the universe, and requires no invocation of exotic, unproven concepts. But the humor in the story lies in how often the simplest natural explanation is also the most complex and statistically contorted. The scientific explanation for the 12 anomalies is a daisy chain of low probability events. It is a narrative that requires you to believe, simultaneously, in a natural rock that is 7 billion years old, has the structural integrity of a monolith, has a retrograde orbit with a precise, low 5-degree inclination, and fires a jet toward the sun due to a complex, perfectly balanced rotational geometry. The sheer improbability of this one object clustering all of those unique, low probability traits is what keeps the tension alive. The human response to this tension has been extraordinary. Social media is flooded with speculation. Podcasts dissect every Hubble image, looking for hidden details. The search for truth about 3I Atlas has become a cultural phenomenon, filling the information vacuum much faster than official sources can respond. The moment has become a public referendum on the boundary between science and wonder. The scientific rigor of the past few months has been immense. The sheer effort of the follow-up observations, the modeling efforts, the debates in journals and conferences has been a testament to the dedication of the scientific community. Whether the conclusion is natural or artificial, the process itself is the triumph of the human intellect. And what if we are wrong? What if the rigorous adherence to the natural hypothesis blinds us to a subtle, obvious sign of an ancient engineering? That possibility is the necessary engine of scientific doubt. It is what prevents our models from becoming dogma. The 2025 Nobel Prize in Physics, which showed that the quantum weirdness extends to the macroscopic world, is a quiet reminder that our understanding of reality is always in flux. The laws of nature are not set in stone. They are always being revised at the edges. And 3I Atlas is forcing us to revise the law on interstellar visitors. The final conclusion, the one that will accompany you into your deepest rest, is that the journey toward understanding is the true reward. Whether we find alien worlds or just nature at its most extreme, we are learning, we are growing, and we are becoming the species that can ask these questions and have some hope of answering them. We are not just looking at a comet, we are looking at our own reflection. We have traced the journey of 3I Atlas, from the improbable shape of its teardrop coma to the statistical defiance of its low-inclination orbit. We have listened to the whispers of its ancient origin, possibly 7 billion years ago, and examined the chemical signature that marks it as a fossil from a different galactic era. We have weighed the twin narratives of natural outlier and technological artifact, and we have felt the tension between scientific rigor and profound wonder. As our journey nears its end, we must confront the final, quiet question. What does the messenger mean? 3I Atlas is receding now. Soon it will be too far and too faint for even our best instruments to track, dissolving back into the infinite dark from which it emerged. Before it becomes just another invisible speck, it leaves us with a legacy that transcends the simple classification of comet or probe. The messenger means, first and foremost, that we are not alone in our cosmic experiences. If 3I Atlas is natural, it is a piece of chemistry forged in a distant star system, a sample of matter ejected from a planetary nursery that we will never observe directly. It connects us to the universal processes of star formation, the random violence of gravitational slingshots, and the immense, lonely duration of cosmic drift. We are connected, through this one object, to the geology and chemistry of a star whose light has never touched Earth. The messenger also means that the universe is far more complex than our models suggest. Every anomaly, the extreme polarization, the sunward jet, the non-fragmentation, is a lesson in humility, a reminder that the edge cases of nature are spectacular. The quiet mystery of 3I Atlas is the mystery of the vast, unexplored parameter space. It tells us that we have only just begun to lift the rock and discover the new species of phenomena that were always there, waiting to be found. The human meaning of the messenger is an affirmation of our relentless curiosity. We are the species that sees a strange object passing through our cosmic neighborhood and asks, not just what it is, but what it means. We are the ones who built the Hubble and the James Webb Space Telescope and the Trace Gas Orbiter on Mars. This entire, complex, multi-layered story is a testament to our technological and intellectual drive. And finally, the messenger holds the possibility that the boundary between natural and artificial is not as clear as we thought. Whether 3I Atlas is an ancient, durable rock or an ancient, durable probe, it has forced us to confront the question of intelligence in the cosmos. It has made the Fermi paradox immediate and real. We have seen the evidence, we have analyzed the data, and we are left with a lingering, powerful ambiguity that science cannot yet resolve with confidence. The reveal on November 19th, 2025 will come and go. The data will be shared, the interpretations debated, and the slow, painstaking process of convergence will begin. But for one moment, when the new imagery appeared on screens around the world, we were all looking at the same thing. A visitor from the stars, a messenger carrying stories we have waited our entire species' history to hear. The stars are waiting. The questions remain. And somewhere out there, moving through the dark, an object that does not quite make sense, is carrying answers we are only beginning to formulate the questions for. That is the story of 3I Atlas. Our long journey with the ancient traveler, 3I Atlas, is at an end. We have seen the evidence, felt the weight of 7 billion years of history, and reflected on the magnificent improbability of our own moment in time. Our ancestors survived the primal soup that might kill you, and we have survived the chaos of data to arrive at a beautiful, quiet mystery. History bends, but it never breaks. We have pushed the boundaries of our knowledge, and whether we found aliens or just alien worlds, we are forever changed by the asking.